So this is a very delayed presentation from Down Tools Week that I didn't get to do because I was away. So I sat around thinking about writing stuff in the cloud like we are for cloud services and why this is so hard and why I seem to be reinventing the wheel every 5 minutes. And then I started thinking about how we write websites these days, thinking about MVC and Rails and how we don't worry about redefining the wheel each time. We have convention rather than configuration, and we have runtime binding, and we just focus on writing the business code of what our website is going to do rather than thinking about exactly how we're going to push bits to the web browser and how we're going to get HTML to display on the client. So the first thing I did is I whipped out the entire of the boilerplate for your worker role in MVC and replaced it with my magic class, which is part of the framework. So I have here a solution, and I've got a worker role. So this is a headless role that runs in Azure Compute nodes. And I've got an MVC web role, which is just a generic web project. And then I have my Azure definition here, which says I have the web role and the worker role and how it's going to deploy into the Azure fabric. And then I've got some NuGet stuff. So if we start off in the MVC stuff, which you'll probably seen before, I have a single controller, apart from the home and account controller, which is just the standard boilerplate that came with it. And I've got two pages. One's the index page, and then a second page is to show images. So I'm going to do a cloud service to take the Twitter sphere by storm about doing stuff to images of cute animals, because I couldn't think of a better idea. So what we're going to do is we're going to rotate pictures of cute animals, and so many people are going to want to do this, we're going to have to do it in the cloud at like cloud scale. So you need hundreds of machines rotating images of cats, but you can substitute something useful for this. So the way the two halves actually interface is that I have a client library, and I initialize this with a string which defines the set of tasks that I'm going to be talking to, and then I have a connection string, and this is going to be specifying where in Azure I'm going to be using to store all my images and the queuing system I'm using. I realise time's going to waste, this will be really, really quick. So let's do an interactive demo, and I'll quickly go between the code and actually what's running. So this is just loading it all up in the Azure emulator, so I don't actually have to run it in Azure, and I can debug it locally. So what I'm going to do is I'm going to click here, and I'm going to collect an adorable kitten, and then I'm going to hit, and then when I hit upload, oh gosh, sorry. When I hit upload, it's going to get the file. Stream from ASP.NET MVC. It's going to upload that to an Azure blob, and then it's going to queue a task, and I have a task called image, and that task has an action called rotate, and then in a very MVC way I'm passing in an anonymous object which is going to have one property called file name, which will have the file name in Azure, and then that's then going to go through to my worker role. So my worker role has a set of tasks that are defined, which are just normal classes that inherit from worker task, and that's going to have a method called rotate, and that method name matches the string that's passed through, and has an argument called file name, which matches the anonymous object that I've passed through. This is then going to read the file from Azure, it's then going to do some image rotation, and then write them back to Azure, and then signal a success back. So this is the only code that's in my the worker role. I'm just writing the business code, which is a method. All of the marshalling into the method, all of the marshalling out of the method has been done for me by the framework. So when I upload the image, it waits to process because this is an asynchronous thing, and now I have an upside down kitty, which is great. This is not revolutionary, but what I'm going to do is quickly add a feature to this in the 60 seconds I have remaining. So in my image controller, what I want to actually do is take a file, and I want to take a string, and that string is going to be passed. Oh my god, where have the function keys gone? No. Okay, I'm going to. Oh, I think I can do. There we go, found it. Right. That didn't work. Oh no! Oh god! Never write code live. Okay, so where's no? That's completely the wrong place. Okay, let's go to. Let's actually try. So I'm going to go to my view, I'm going to go into the image views, index. So I'm going to, just give me an extra 60 seconds and pretend that didn't go off. Oh. Visual Studio is not with me today. So I'm just going to add a text box there. So that's going to then pass through to my MVC controller where I've added message. And then I'm just going to add that to the anonymous object. I can then go into my image task and then add similarly the same parameter there. So that's going to be marshaled through with reflection. I then have some cunning code here, which if I add that, and then I can take off the flip. So I've decided that customers didn't really want to have their kitty flip. They actually wanted to be able to add messages to their images because they don't own a copy of Paint. And then I also need to make sure that I'm expecting lots and lots of people to want to do this. So I can then go into Azure and say that I'll probably want, maybe 4 copies of the website. Adding text to images is really expensive, so I'll have 10 copies of the actual background processing node. So I'll kick that all off. So if I bring up the Azure compute fabric, come on, it takes a while to spin up 10 processes on my machine.
It's webscale.
It is webscale once it's running. If anyone's actually used any of the cloud stuff, you'll know that deployment is actually not the fastest bit. That's displaying on a different monitor. There we go. So you can actually see I do have my 4 web servers and I have my 10 compute nodes all running in emulation. And I can now find a different kitten. Oh, I forgot to type a message. And now I have text on my kitten, and I did that on 10 nodes simultaneously. So if you were just pushing requests in, they would be farmed out via the Azure queues, and then the responses would be marshaled back through Azure tables. But you didn't have to worry about any of the implementation detail because no one wants to do all the pipes. People just want to solve their business problems. So this was trying to make it very, very easy to write something that's cloud scale. Yet at no point did I explain how the blob storage system works or how queues works. I just treated it like C#. Sorry, I overran. Questions? Yeah.
Does nothing equivalent exist already? Is there no Azure framework?
No, Azure at the moment is mostly the component parts. You have queues, you have storage, you have a functional entry point into Azure where you run your method and you have to start building everything up from scratch. So one thing I didn't demonstrate there, for example, is if I'd made a typo in the text processing and thrown an exception, the code I've written catches that exception, marshals it back into table storage, and then when the web service then requests the result for that task, then it would display the errors back in the UI. Also, if a node gets shut down while processing, that work item is persisted in the queuing system until a node either successfully or unsuccessfully processes it. But if something suddenly dies, it will get resumed, so things are durable as well.
So I think Theo has something where one of the dependency injection frameworks supports Azure quite well. Is that actually true?
I'm not sure in what way it means it supports Azure. So
it makes so that when you call a method on your DI framework, the interface,
okay,
the actual implementation of the interface is held on is running on the compute node.
Yeah.
So when you're running on your SPNet web app and you ask your DI framework for the interface, it just gives you a proxy stub thing. So when you call methods on it, reinvokes on the compute node. So
that sounds great in the same way that RPC sounds great. And while you want something that hides detail, you probably don't want it to look like a method call, because if you do that, then you're not going to be expecting it to throw crazy exceptions or never return or do all the stuff that RPC and message passing task-based systems do that function calls don't do.
So how's that different to what you've done?
So this isn't, although let's go back to the code very quickly. If I go to the controller, what you actually do is you call QTask and you're returned an object that's your ID, which is a token, And then later on, to get the status, what you do is you get the client and you ask for the result. So you have to poll for the result. And it will either tell you that the task is still pending, the task completed successfully, and here's your data, or the task completed with an error, and here's your data. So it's still something you have to poll.
Link it with async.
How does that help?
Well, depends on what you task. You say you do something async, but
Yes, but the thing is, we're generally out in browser mode, so people will be writing JavaScript, which will then ask for the result of that task. You're not generally waiting in C#. Cool. It's very, very rough and ready, but if you wanted to play, come see me. I can get you access to the source code.